This is James Turner of O'Reilly News. I'm talking with Alex Martelli, who is the Uber tech lead at Google and is speaking at OSCON this year on code review, especially as it relates to open source. Hi, Alex.
That's correct. Hi.
So, tell me a little bit about what you think the challenges are that open source projects have with code reviews.
So, my colleague Brian Fitzpatrick has this great line of talk about why don't people commit their code until they have 2,000 lines and they've blocked everything for 3 months? Because they want to be perfect. They don't want to have any errors be seen by anybody at all. They want to be perfect developers. Their mistake is they see perfection as a state rather than a process. We're human. We're never going to be perfect. We can become more perfect. So code reviews are very much a tool to help us become better, help our code become better. The problem, particularly in an open source environment where there is no coercion except social pressure from your peers, is that a code review implicitly is about errors you made or imperfections at the very least. You could have named that variable number of widgets, so why do you name it n so nobody understands what it's for? So if you are uncertain of yourself, if you're terrified to ever be caught in a mistake, then code reviews are perceived as, well, their purpose is to catch me making an error. I'm perfect, I don't make mistakes. So that's the mentality we have to fight, basically accepting that we make mistakes, and the purpose of the whole thing is help us fix them, help us learn, help us make new mistakes next time, because we've learned not to make the same ones again.
Now, I've been involved in several open source projects, and frankly, some of them, it seems like there is no code review at all.
It can get close to that, particularly when most of the source ends up being committed by a few extremely famous, strong, great developers. There may be so many other hanging around, finding bugs and things, but they perceive themselves as not in the same class, not in the same level as the big guys, and so they're intimidated. How could I possibly criticize this superstar who codes 10 times better than I ever will? So they say nothing. That, I think, is one possibility. Even when the superstar in question is the humblest and most accessible person on earth, he may still intimidate just because he's so good. And of course, not all great programmers have that egoless quality that makes them humble and ready to accept criticism, so the error may be on both sides. I have a solution I like to dwell on for that. Instead of criticizing, ask. Instead of saying, this function will break if the argument is 0, which is a direct criticism, an accusation, so the beginning programmer will be afraid to criticize directly the experienced one, and the experienced one may get defensive and offended at the insult. Instead of saying, this will break if the argument is 0, ask in the code review, so what happens if the argument is 0? This is not a criticism.
Or maybe even as, you know, is it possible that this could ever have a 0 pass to it?
And what happens if it does? So from the point of view of the newbie who's intimidated, he can frame this in his mind as, I'm not criticizing, I'm trying to learn at the feet of the great programmer. And one way of learning is ask questions. From the point of view of even the most ego-fragile big guy, this will not be perceived as an attack, and yet it may lead to the same purposes, as in, whoops, I'd better take care of that, or put in a comment explaining why it can never happen. Either way, the code gets better. Without any clash of ego, without any conflict. I don't think conflict is inherently bad, but it takes people with great clarity, integrity, and humbleness to use conflict constructively. And, you know, there's not all that many of those going around.
Now, in some of the Apache projects I've worked on, for example, they tended to use an empty bug list as their metric for the codes ready to ship, without much inspection of the code itself at all. I think part of it was, at least in most of the projects I worked on, again, the 8 or 10 real lead programmers on it lived in the code constantly. And I think there was this concept that, they just grokked the code and could understand very quickly if something was...
Far be it from me to criticize Apache, which is one of the most incredibly successful example of open source code. But in most real-life cases, we'd really like to make it possible and actually interesting for new people to step on board gradually. If the only kind of water you have is a maelstrom going on, and that doesn't matter because only the 8 best swimmers in the world are there, how will the new blood ever get into the project if you have to be perfect before you can try? I'd like to have some things that a newbie can do or attempt without needing to grok a million lines of code. And this requires simplicity, clarity, all sort of things that don't necessarily have to do with bugs, although they may, complications and obscurity can hide bugs in this sense, cause them, but they have a lot to do with how easy it is to step into the code base and work with something without needing to become familiar with everything to start with. So style, uniform style, good variable names, that sort of things.
In the commercial environments that I've worked in recently, it seems like TDD seems to be taking the place of code review. The idea being, we don't care how good the code is as long as it passes all the tests that we can think of it could break it.
That's very short-sighted. I love TDD, don't get me wrong. I've heard the same argument made for pair programming. We do pair programming so we don't need code reviews because there's already 2 people have looked at it. So my counter-arguments are slightly different for the 2 cases. For TDD, not caring about the quality of the code, well, so TDD was born in the atmosphere of extreme programming, which also coined such uses as code smells. Code smells are not things that exhibit themselves in outside bugs, but what they have to do is, like, there's repetition in this code. So there's no bug right now, but the first time you fix one of the 3 almost identical copies of the code, you will forget to fix the other 2, and if the tests don't check that all 3 behave sensibly, you're in for a world of pain. Testing is crucial, but you cannot rely on it 100%. There's things human eyes will catch, such as function A, B, and C are almost the same. Why don't you factor out the commonalities and just have the differences in A, B, and C, or even more common for objects than for functions. And as for pair programming, which is the other thing that I've seen proposed to take the place of code reviews, the problem is that, particularly if you sit often with the same person, you work together, you start thinking very much the same. You get in sync. It's actually very productive when you're both thinking in very well-aligned ways. So it would be wrong to try and counteract that, but the fact that you're thinking in very much the same way means that the same thing that is obviously clear to both of you will not be clear to a third person who wasn't sitting there for 3 hours with you.
Because he doesn't know the backstory.
So you actually need a comment or some clarification or a more expanded name, but neither of you sees it anymore because you're so familiar with that work and you're thinking about it the same way. So while the code review, if you have excellent test coverage, the code reviewer doesn't have to worry about many tests. I make a point. There are some things that test are particularly bad at catching. If you do multitasking programs, race conditions, you will never be able to set up the test to catch all possible race conditions. Deadlocks, not quite as bad, but is also very hard to catch. So if you have any of that, your only hope is to have a very clear, sharp architecture and very sharp eyes watching for any deviation from that architecture's attempts to cut corners or the like, because testing is not going to save you in that kind of thing.
One of the issues I've seen with formalized code reviews is there are kind of two extremes I see and very little in the middle. One extreme is the let's get out of here as quickly as we possibly can, and yeah, great, fine, it all looks great. And the other extreme is the we must demonstrate that we had a good code review, so let us nitpick to death every
Absolutely.
little thing.
The first one is exemplified by a wonderful T-shirt I've seen at I believe it's ThinkGeek, with a rubber stamp LGTM, which is a look good to me acronym that people use to bless the final form of code review. If people rubber stamp it, it means that they've been forced to do it. It's easier to think of forcing people to do something in a commercial environment because, well, if you don't play by the rules, you're fired or something. But even in an open source environment, there's social pressure, which sometimes can be very strong. So I hate doing code reviews, but yes, I accept that to play this wonderful team I have to, and still I don't want to, so I want them over quick. And so I just rubber stamp things. So this is very much a social problem. My friend and colleague Fitz is the expert of social problems, and he's got all sort of suggestions for dealing with those. It's basically a question of building a real shared culture, not just the veneer of one. So if you start with a small core team which shares values, and the entrance of newbies is kind of conditional on not just making the right move, but really accepting the culture, in the long run, you end up with a very viable and culturally aligned team, and people will see code reviews as value, not as something to get away from. As for the other extreme, well, for the other extreme, I've seen it happen much worse outside of open source because of, code reviews have been around forever in informal ways, but it was in the mid-70s that Feijin at IBM decided they deserved a bigger place, and of course way overdid it with an extreme amount of formality. Code reviewers are designated, they have to meet in the same room after each of them spending many hours studying all the source code. I don't think there's all that much of that still going around in most commercial environments, because the commercial environments in many cases have become very competitive. You just can't afford to take 5 years to release something your competition will release in 2. But there are still places such as where you're operating under contract, exclusive contract with the government, for example, where basically you are being paid by the process. So the heavier your process, the bigger the costs of developing software, the more money you're going to make.
I've seen places that actually metric on how much is found in code reviews. So, it could be beautiful code, but if you haven't found your 6 defects you had to find in it, then...
Yep. Yeah, the counteraction to that, of course, is an application of a technique which is actually a perfectly valid coverage testing technique known as defect injection. Defect injection is a perfectly valid technique. You basically, to check that your test suite doesn't just cover lines, but actually cover paths and so on, you randomly inject a number of defects and check how many of those are caught. And this is actually very useful. But if I ever worked in a environment like that, well, I would insert 10 known defects in the code before review, and if the reviewers don't find them, I'd whisper to them so we could meet our metric, and I'll be happy, and then we'll reward it. It seems people put metrics in place. Metrics can be fine. I don't have anything against them, and then transparently use them to reward or punish people or drive things. Don't they understand incentives? People respond to incentives. If you pay by the line of code, you will get very long and verbose comment. If you pay by the line of code excluding comments, you will get no comments. Just very long-winded code. obvious.
Yeah, those are sliding down.
Yep.
There we go. So something I've noticed is that there don't seem to be a lot of good tools out there, at least what I've found, to assist in code reviewing.
Now, this is fortunately changing. My colleague Guido van Rossum, the chief architect of Python, as his started project at Google a couple years ago, developed a code review web application called Mondrian. It was like intended to be a startup project, things you do in the first 3 or 4 months to learn the environment. It proved so incredibly useful that he had a hard time getting away from it for a full year, and is probably now the single piece of code most heavily internally used by engineers at Google. It's called Mondrian. He gave a presentation of it you can find on Google Video. Unfortunately, we always planned to open source it. Unfortunately, it ended up being so dependent, so entwined with internal Google technologies and our main code repository, which is a commercial product, Perforce, that it wouldn't really be very useful to open source as it stands. So Guido then moved to develop the Google application engine, and as a basically proof of concept that all the needed pieces was there, he developed a lightweight version of Mondrian for the Google application engine. It's called Rietveld. So Mondrian was a painter, Dutch painter, you know Guido's Dutch, and Rietveld was a very important architect. R-I-E-T-V-E-L-D, Rietveld. And so that's open source, and it's freely available on CodeGoogle.com. And there's also an instance running at codereview.appspot.com. I'm not saying that is the way to do things because, for example, it only supports Subversion right now. But it is open source. It's very clear code if you want to add Mercurial support or JIT support or whatever other, there are all the hooks in places. The cool things is that it's hosted, so you don't even have to provide your own host, you can just run it there. If you are up to running stuff on your own host, as most open source projects will be, our friends at VMware have open sourced the system they use for code review. I will present more details on all of these in my talk. What I do find interesting is that all of these tools are in Python. I wasn't looking for just tools written, no, there's one in Perl actually. I wasn't looking just for tools written in Python, but 3 out of 4 of the main open source code review engines. Code review is mostly a front-end issue because, you know, the back end is there. People mail diff or patch files around in most projects. It kind of works. I mean, there's not a horrible need, but once you've started using one of these nice things, you just click there, enter a comment, or respond to an existing comment. One thing none of them have that would be a great next generation is for the author to accept a comment by changing the code in situ. So often, the changes you do for a code review are not huge, big things. Are change one name and just throughout, or change a couple of lines, add a test, a few lines of code at a time that could very well be done without all the power of Emacs or Vim at your disposal. And it would be nice to have this little extra feature in those tools. But they're all open source, so pick your favorite, either the Perl one or any of the Python ones, and there's going to be plenty of fun to be had with that.
Do you think there's something in the Python culture that has made them more driven to be code review oriented?
I don't know. I do have a lot of connections with the Python culture, but particularly where I work, but also in projects where my friends work, like at VMware and other companies, I see C++ and Java subject to equally strict criteria. Maybe a little bit less for other languages such as Perl or JavaScript, languages where sometimes being obscure as opposed to clear and obvious is seen as a cool thing, a clever thing. There's something about code reviews where cleverness just doesn't really work right because you have to explain and keep explaining. Why do you do that? What does this thing do? if you have clarity, simplicity, and lack of cleverness as values, like most Java programmers, C++ programmers, and Python programmers, that kind of works with the grain of code reviews. If the cleverness aspects are seen as positive, then that doesn't really work out quite as well. So that may be the cultural difference. I don't think it's all that sharp. I mean, you can perfectly well write the plainest JavaScript, clear to even the lowest beginner, and then just run a minifier and get all the... there's no reason to write your JavaScript with single letter variable name to make it shorter. You can do a compile, so to speak, and get the one character names after the fact, and still maintain the source code and without choking the browser. So there's no real reason, but maybe there's, back in the culture before minifiers existed, people got used to doing that, you know.
Well, Alex, thank you very much for talking to us about code reviews.
Great questions.
It's definitely been an interesting thing for me to think about.
Thanks.
Thank you.